you are using copper alloy as your filler material. So it could be copper zinc or copper silver, and similar process with some alloy of lead and tin based alloy. So for soldering, it would be lead and tin based tin based alloy for soldering purpose, which are you using as the filler material, right? And what is the most common heat source for these processes? The most common heat source is electrical resistance heating. So both for brazing and soldering provide electrical resistance heating, right? So of course there are a lot of metallurgy includes into this welding thing. So there are a different segment of welding metallurgy, which is vast in nature, of course. Um, let's not go into that direction. Anyhow, we are in our introductory class. Uh, now, what are two distinct advantages of this class of joining processes, like soldering or brazing? Anybody? So here, the heating of the parent material is negligible to cause any change in their structural properties, right? Whenever you heat up any material, it will create some anisotropy into the material. So because the melting temperature of your filler material is lower than your parent material, the heating of this parent material, we tell it negligible to cause any change in their structural properties. And second, uh, the processes can join to materials which are insoluble in which are insoluble in each other. These I had mentioned earlier also. Now, to produce a perfect joint, your entire gap between those parent bodies that must be filled up by the filler material, and yeah, this is achieved essentially some kind of capillary action or fluid flow is happening. So yeah, there is this liquid metal flow into the gap. So that's what I was telling as capillary action of the molten metal, and because of melting and solidification you are getting some joint over there.